Okay, so the next question, question 5, is all about entropy and also Gibbs free energy delta G. So, titanium 4 chloride can be made from titanium 4 oxide as shown in the equation. There's the equation, and you've got the enthalpy change, negative 60 kilojoules per mole. And then you've got the entropy in joules per Kelvin per mole of the different substances that you've got in the equation above. Use the equation and the data in table 3 to calculate Gibbs free energy change for this reaction at 989 degrees Celsius. Give your answer to the appropriate number of significant figures. Use your answer to explain whether the reaction is feasible, and this is worth 6 marks. Okay, so there's a few number of different things that we've got to do in this question. The first one is we're going to have to calculate the entropy change for the above reaction using the data in the table, and then we're going to have to calculate delta G once we've got the entropy change for the reaction. So to begin with, delta S is going to be equal to the sum of the entropy of the products take away the sum of the entropy of the reactants. Okay, so products, carbon monoxide and titanium chloride, products, and then my reactants, I'm going to give an R at the top. So I'm going to start with my carbon monoxide, 198. I'm going to check my equation. I've got 2 of them, so I need 2 lots of 198. Add 253 for my titanium chloride. I've just got 1 of those, so I can keep that as it is. Then take away my reactants. So what have I got first? Titanium oxide, 50.2. I've just got 1 of those, so that stays as it is. Then comes carbon. I've got 2 lots of 5.70, so that's done. And then I've got chlorine, which is 2 lots of 223. If I work out that, I get 141.4 joules per Kelvin per mole, and quite handily I've got the units there. Okay, now so just before we move on and have a look at this a little bit further, the mark scheme says I just get 1 mark for stating that equation there. So it's always useful, it's always worth doing something in an exam question. I get another mark if I've worked out 141.4 joules per Kelvin per mole. And then before I'm going to look at working out whether the reaction is feasible or not, what I'm going to do is I'm going to convert this, so the entropy is given in joules per Kelvin per mole, into kilojoules per Kelvin per mole, so that it can fit into the delta G and delta H equation, which are given in kilojoules per mole. So to do that, I need to go from joules into kilojoules, so I need to divide by 1,000, which would get me 141.4 times 10 to the negative 3 kilojoules per Kelvin per mole. Okay, and if you do that in this question, you got 1 mark, and that's a really common error that students forget about in an exam, that entropy is in joules and enthalpy and Gibbs free energy are in kilojoules per mole. Okay, so the next thing I'm going to do is work out whether the reaction is feasible. So I'm going to calculate Gibbs free energy. So I'm going to need this equation here. Delta G is equal to delta H, take T delta S. And if you wrote that equation down in this question, you also got 1 mark. So if you think about 2 of the 6 marks for this question, a third of the marks come from remembering the entropy equation and the delta G equation. So 2 really important equations to remember. So Gibbs free energy is going to equal the enthalpy change, negative 60.0. Take away the temperature, so the temperature is given is 989 degrees Celsius. I need that in Kelvin, so I need to do 989 add 273 gets me 1262. And then I need to multiply that by my entropy, 141 times 10 to the negative 3. And then that gets me a delta G value of negative 238 kilojoules per mole. So, let's go back to the mark scheme for this. I got 1 mark if I put the correct numbers into this equation, and I get 1 mark for my answer, which is negative 238 to the appropriate number of significant figures. So in my data in my question up here, all the data is given to 3 significant figures, so I'm going to need to give my answer to 3 significant figures. And so far I've got 1, 2, 3, 4, 5, 6 marks. I think I've given myself an extra mark somewhere. I'll work that out in a minute. So you need to say whether the reaction is feasible, and yes, it is feasible. So I'm going to put feasible as delta G is negative or less than 0. Let's work out where I've given myself an extra mark. It is this bit here. So I would pick up that mark for converting into kilojoules in this mark here. So that's better because now I've got 6 marks again, 1 mark for my explanation, and my other marks for working out that. So this is a kind of a standard question in the exam, and it's fairly straightforward as long as you can remember those 2 equations. Okay,